problem? We had the baseball problem? Yeah. Okay, cool. You guys kind of got the gist of it. So baseball was hit. Origin point was 0, 0, 3 in the coordinate system because the z-axis represents the vertical. So we started with the acceleration function. We integrated the acceleration function to get the velocity function, or the velocity vector function. But we integrated the acceleration to get the velocity. We accounted for the constants with the z vector, with the constants vector. We then set the velocity equal to 0 to figure out our constants, which ended up being the constants 1, 2, and 3, ended up accounting for 80, 75, and 60. We then plugged in our constants into our integrated velocity vector to get our complete velocity vector function. So after we got that, we had to integrate one more time to find the position. So we integrated the velocity to find the position, which ended up with a whole new set of constants. So we had to find the set of constants for the position vector. We set everything to 0, the t is equal to 0, to find the constants, and we ended up with the original position, which was stated in the question, which kind of made sense, right? So the original position was 0, 0, 3. Those represented the constants. We plugged them in to get our complete position vector function. And after we got that, we had to figure out at what point the ball hit the ground. So we wanted the z-axis to be equal to 0 at that point. Or I should say we wanted to focus on the z-axis. So we only took the function that was in the z-axis, which was this negative 16t squared plus 60t plus 3. After we separated that function out, we took the quadratic. We had to use a quadratic to find the time intervals for when it would equal to 0. Now we got two answers. One was ridiculous. It was a negative number, negative 0.4049. The other one gave us 3.8. So that was our 3.8 seconds value that we ended up plugging in to our complete velocity function. And that ended up giving us the velocity vector at the time, 3.8 seconds, which is when the ball should hit the ground. So after we plugged it in, we solved for it, our velocity vector ended up coming out to 87.5, 75, and negative 61.6. Now that gave us the velocity vector, but the question was to find the speed at impact, and speed is a scalar value. So we had to take the magnitude of the velocity function, and that gave us the speed at impact, which was 130.74 feet per second. Any questions? Yes, because the constant accounted for 3 from the original position, where 3 was in the z-axis, so we plugged in the constants to at the end there. So it ended up becoming 16t squared plus 60t plus constant 3, and then plugging in 3, we ended up getting this function right here.
It's basically what we did, because we just made it equal to negative 3.
Negative 3, yeah. Oh, okay, so you accounted for it at the end rather than at the beginning. Okay, I got you. I noticed there was a couple other groups that did that as well. We were considering that because we kind of got confused when it said the origin point at the beginning, so we kind of thought it meant origin as in set your coordinate system to 0, 0, 0, because that would be the origin. After discussion, somebody in my group, smarter person than me, ended up figuring out, hey, you know what? That's the 3 feet in the z-axis, which accounted for the height from where the ball got hit with the bat. I will say, yeah, after that, it was just a matter of separating which component in the coordinate system represented the height to find out when the ball would hit the ground. Because we want to find out when the height is 0, so we know that's the point when the ball hit the ground. And then solving for t in that sense. And that's what gave us our t values. One was ridiculous, as all, quadratic equations come out to. The 3.8 seconds ended up becoming our time to when the ball hit the ground. And then that was just like a plug and chug after that. And then solving, of course, for speed rather than just the vector. Multiple steps in integration, plugging in, finding constants. What else? I'll say the only thing probably that's confusing about it, we use the constants vector rather than plugging in the constants into each component. But other than that, it worked out nicely.